This video is going to cover Chapter P, Section 2, Part 4, which is simplifying radicals. So how do we simplify a radical? We're going to use a factor tree to simplify. When the index is 2, which means the square root, which looks like this, because there's really a 2 there. When that index is 2, then you need 2 of a repeated number in order to bring the number to the outside. So let's just say we had this square root of 20. We would break that down into its factors. So because 20 is even, 2 goes into it 10 times, and then 10 would be 2 and 5. So you want to break it down until it's prime, until you can't go any further. Then you want to look at these dead ends where you're stopped, which in this case is 2, 2, and 5. And you want to see if a number repeats. 2 repeats. So for each pair of 2s, 1, 2 can get taken to the outside of the radical. And then this 5 that doesn't have a pair would stay underneath. So it ends up being 2 square root 5. You can also see that as 20 equals 4 times 5, and the square root of 4, is 2. The more complicated the number gets, the more factors it has, the easier it's going to be to do that first way. If you're going to multiply 2 square roots or 2 cube roots, you can as long as the index is the same. So in this case, they're both square roots, which means we can multiply. We keep the root and we multiply out the numbers underneath. So 2 times 3 would be square root 6. 6 would break down back to 2 and 3 and nothing repeats, so we would keep it as square root 6. And lastly, when we're dividing with a square root, if there's a square root in the top and a square root in the bottom, you can actually reduce them. Divide one number into the other, whichever goes into the other, and keep the radical where the number is left. So this would be 1, square root of 1 is just 1, and this ends up being just square root 2. If it was reversed, if the square root 10 was in the bottom and the square root 5 was in the top, then this would be 1 over square root 2. All right, let's work through some examples. So the directions will just say simplify. I'm going to look at square root 28 and say, okay, I know square root 28 can get broken down. 28 would be 2 and 14, which is 2 and 7, and those are all prime. I need one pair of numbers to go to the outside. Here's my pair of 2s, so a 2 goes to the outside, and the 7 is left underneath. Number 2 is 48. 48 is 2 and 24, 2 and 12, 2 and 6, 2 and 3. So there's a lot of different ways to start to break down 48. You could have done 4 and 12. You could have done 6 and 8. But all of those numbers would eventually get broken down to be the same factors. Now for each pair of numbers, that one number is going to the outside. So a pair of 2s means 1, 2 goes to the outside. Second pair of 2s brings another 2 to the outside. There's 1, 3 without a match. That stays underneath. And then if we bring out more than one number or leave under the radical more than one number, we multiply them together. So this becomes 4 square root 3. Number 3, 2 square root 48. So now I can break down 48 the same way we just did. 2 and 24, 2 and 12, 2 and 6, 2 and 3. There's one pair of 2s coming to the outside, a second pair coming to the outside. Now there's already a 2 there, so I multiply all 3 of those out. 2 times 2 is 4, times 2 is 8, and the 3 is left underneath. $45 would be 5 and 9, 3 and 3. Pair of 3s comes to the outside, gets multiplied by the 6 that's already there. So that's 18, and the 5 is left by itself, square root 5. Okay, continuing on the same process. number 5, 14 times the square root of 75. 75 is 3 and 25, which is 5 and 5. The two 5s go to the outside and get multiplied by that 14. 70's on the outside, and 3 is left underneath. We go to 6. 10 square root 125. So 125, again, we can break down more than one way, but I know 5 goes into it. 25 times. 25 breaks down into 5 and 5 again. Now there's 3 5s, but my index is 2, so only 2 go to the outside as 1. The other one's going to get left underneath the radical. So 10 times 5 is 50 on the outside, square root 5. Seven, 600 breaks down into 2 and 300, which is 2 and 150, which is 2 and 75, 5 and 15, 3 and 5. Again, you can break that down a lot of different ways. I could have done 6 and 100 and then just kept going from there. As long as at the end you get to all prime numbers, it doesn't matter how you get there. Now let's count the pairs. Here's a pair of 2s. It's going to come to the outside with the 5. And then there's a 2, but another 2 doesn't repeat, so that 2 is going to get left underneath. There's 2 5s, so a 5 gets brought out. And then there's a 3 without a match. That's going to stay underneath. So on the outside, I have 5 times 2 times 5, and underneath the radical, I have 2 times 3. This is 10 times 5, which is 50, square root 6. Eight is 5 root 3 times 2 root 3. So we've got coefficients and square roots. We're going to multiply together the coefficients. So 5 times 2 is 10. And then we have a couple of things we can do here. Either multiply 3 times 3 underneath the radical, and that gets me square root 9. But then I'm just going to square root that to get it back to the 3, and I end up with a 30. The other option is to group together the coefficients again, so 5 times 2, and then keep the square root of that 3 times 3 underneath. Now 3 times 3 is like the end of the factor tree. I'm broken down into 3 times 3. There's 2 of the same number, so I can bring 1 to the outside. So now I've got 5 times 2 times 3, and nothing left underneath the square root, which would be like the square root of 1, which stays as 1. Here we get 10 times 3, which is 30. So it doesn't matter which way you do that, you always end up with that same answer. All right, number 9, square root 5 times square root 5 times square root 9. Everything's underneath the radical. This square root 5 times square root 5 just becomes 5. Square root 9 would be 3, and this is 15. Ten is 11 and 44 underneath the radical. So I can make that one radical. 44 would be 4 and 11. 4 is 2 and 2. So there's a pair of 2's that goes to the outside of the radical and a pair of 11's that joins it, making this 22. 11 is square root 11 and square root 33. So square root 11 stays. 33 would be 3 times 11. 11 repeats. So I bring that to the outside. 3 stays underneath. (12) 6 square root 7 over square root 35. Now there's two things underneath the square root here in fraction form. They're both divisible by 7, so this would be 1 and this would be 5. And I get 6 over the square root of 5. Now we're going to leave this here for now, but just a little bit, we're going to learn about rationalizing a denominator where we'd have to come back here and simplify this. But for right now, we're going to leave it as it is. Looking at 13, I've got 5 on the outside, 48 and 39 underneath. They're both divisible by 3, so 39 would be 13, 48 would be 16. I get 5. Square root of 16 is 4 over square root 13. And I get 20 over square root 13, which again, in just a moment, we're going to learn to rationalize. But for right now, we can leave as it is. All right, now we're dealing with multiplication and some distribution here. So when you look at something like 14, you've got a square root on the outside, and then you've got a sum or difference on the inside. So we're just going to use our rules of distribution to distribute square root 5 into both of these. So square root 5 times square root 5 minus 2 times square root 5. And the square root 5 times square root 5 is just 5 minus 2 root 5. One of those terms has a root and one does not, so I can't combine them together. That would remain as it is. $15, there's not a sum and difference here, it's just straight up multiplication, but there's 3 terms. So we're going to get all the coefficients together. 3 times negative 2 times 3. And then we're going to look at all the square roots. Square root 2, square root 8, and square root 27. Now I can break 8 down, 2 and 4, 2 and 2. And I can break 27 down, 3 and 9, 3 and 3. And the 2 is already here. So that's one pair of 2s that's going to come to the outside. Second pair of 2s go to the outside. Pair of 3s can go to the outside. And then that last 3 that doesn't have a match is going to be the only thing left underneath the square root. So here I've got 2 times negative 2. 3 times negative 2 times 3 times 2 times 2 times 3. 2 times negative 2 is negative 6. Times 3, negative 18, times 2, negative 36, times 2, negative 72, times 3, negative 216. That's on the outside. And then the 3 stays underneath. All right, looking at 16, 2 things underneath the square root. 6 actually goes into itself once and into 90 15 times. So you're left with 15 over the square root of 15, which is just 3 and 5. Nothing's going to repeat there. So that answer stays for now as is. Last up, 8 square root 3 minus 6 square root 3. So now these are actually like terms. You're subtracting. Both the root is exactly the same. So they both have to be, in order to add or subtract them, they have to both be the same index and the same number underneath. These are both square roots and they're both square roots 3. So I can actually combine these together. I would do 8 minus 6, which is 2. And then I leave the square root of 3 as it is. All right, number 18 says to simplify, you're back to this is a difference. Remember, with a sum or a difference, the square root and what's underneath it has to be the same. So as they are right now, I can't combine these two. What I can do is simplify the individual square roots and then see if I'm able to combine them. So 24 breaks down to 2 and 12, 2 and 6, which is 2 and 3. There's a pair of 2's, so that 2's going to come to the outside, get multiplied by the -2 that's already there, -4. And then 2 and 3 don't repeat, so they get multiplied together and they stay underneath the radical. This 6 would break down to 2 and 3. Again, nothing repeats, so this stays as -3 square root 6. And then because they both have a square root 6, we can combine these into one. I would do -4 minus 3, which is -7 square root 6. $19 is the same, but it's a sum. So again, we're going to break it apart. 45 breaks down into 5 and 9, which is 3 and 3. Pair of 3's comes to the outside. 9 root 5 is the first one. 36 actually gets broken down into 6 and 6, or the square root of 36, which is 6. So this is 42. Because one of them has a root and the other does not, I can't combine them. They stay just the way they are. $23 square root 2 minus 4 square root 63. I'm going to break down that 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2. Pair of 2's comes to the outside. It's going to get multiplied by that 3. A second pair of 2 comes out, and 1 stays underneath. So I get 3 times 2, which is 6, times 2, which is 12. And then square root 2 for the 2 that's left by itself. Minus, and then I work this one out. So this would be, you could do 9 and 8. 9 is 3 and 3. 8 is 2 and 4. 2 and 2. You've got a pair of 3's, so that's going to come out on the front with the 4. You've got a pair of 2's, and that's going to come out on the front. The 2 left underneath is going to stay underneath my radical. So outside I've got 4 times 3, which is 12, times 2, which is 24. And then that 2 that's underneath the radical gives me the square root 2. They both have a square root 2. So now I get 12 minus 24, which is -12 square root 2. Last one, or sorry, second to last one on this slide, 21. Now we're multiplying binomials. So there's 2 parentheses. Inside each parentheses is 2 terms. This is FOILing. So I'm going to multiply the first 2. 4 times 4, which is 16. The outer 2, 4 times a negative square root 11, so minus 4 square root 11. The inner 2, positive 4 square root 11. And the last, negative and a positive, so it's negative square root of 11 times 11, which is just going to be 11. So I'm going to combine together this 16 minus 11, and that's 5. And then I've got a negative 4 root 11 and a positive 4 root 11, so those are going to cancel out, and I'm left with just 5. $22 is the parentheses squared. This is 3 radical 7 minus radical 3 times 3 radical 7 minus radical 3. Be careful. The most common mistake on this is taking this 2 and distributing it to both. You cannot distribute an exponent to a sum or difference, and this is a difference. So we can only do that if it's only multiplication on the inside. So what we want to do here is expand it and FOIL it out. 3 square root 7 times 3 square root 7 is 3 times 3, which is 9. Square root 7 times square root 7, which is just 7. Then outer, so 3 times the square root of 7 times negative root 3 would be negative 3 square root 7 times square root 3. Inner 2, another negative 3 square root 7 times square root 3. And last, negative times a negative is positive. Square root 3 times square root 3 is just 3. So 9 times 7 is 63. minus, and this becomes square root 21, and this becomes square root 21. So negative 3 square root 21 minus 3 square root 21, which we're going to combine that in a minute, plus the 3 at the end. 63 plus 3 is 66. Negative 3 square root 21 minus 3 square root 21 becomes minus 6 square root 21. And that's as simple as we can get it. Okay, so we are going to stop here with the video today. And we're going to pick up with part 2, which is dividing radicals, which is that rationalization, will be on tomorrow's video. So you can start assignment P2C, which starts with the square roots. When you get to ones in which it looks like this and you've got to rationalize that, you can stop and hold that off until tomorrow. Have a great day, guys.